So what have we learned so far this unit about integrals? Well, we have the fundamental theorem of calculus part 1, and this tells me if I have some integral from a to b of f of x dx, well, the way that we solve these is finding the antiderivative, and we evaluate it at b, minus the antiderivative evaluated at a. This is how we solve these. So that's FTC1. And then fundamental theorem of calculus part 2 tells me that the derivative and the integral are inverse functions. So in other words, if I'm looking for the derivative of this integral function from a to x of, let's say, f of t dt, well, all that is differentiation and inverse. They cancel each other out. So my answer is just f of x. But don't forget, we need to use different parameters. A to x, this integral, this is my function. So I need a different parameter inside. And so when I differentiate it, I use the function in terms of x. We've also applied this to chain rule. So for example, let's say I'm looking for the derivative of this function, this area function from a, and I don't know, let's make this x squared. And let's say I have some function t to the third dt. So now I want to find the derivative, but this is not just x, it's x squared, so I need to use chain rule. So x squared derivative of my inside is 2x times the derivative of the whole thing. So again, instead of t, I'm now plugging in x squared, but this is being raised, this t was being cubed, so my input is being cubed. And so my final answer is 2x times x to the 6, which just gives me 2x to the 7th. Final answer. So on the quiz, this was our first problem. And it's just an indefinite integral, so we're just using our integration rules. So if we recall, if we are subtracting two functions, we can split this up. So I can integrate 5x squared, and by constant rule, I can pull the 5 outside. This is x squared dx. Minus, I can pull the 2 outside, and it's the integral of sine of x dx. And now I can just use my integration rules. So it's just 5x squared becomes x cubed over 3 by power rule. I add 1 to my exponent, and whatever that number is, I divide by. Minus, I have 2. Sine x becomes cosine x. So now I know, let's see, if I take the derivative of cosine, I get negative sine. Also, this must be negative cosine of x. And so let's just, it's an indefinite integral, so I cannot forget my plus c. And so altogether, I have 5/3 x cubed. A negative and a negative give me positive 2 cosine x plus c. Final answer. This was number 2 on your quiz. So again, I can treat these separately, but again, an indefinite integral, if I have 1 over x, well, if you forget what this is, just think, what do I take the derivative of to give me 1 over x? And hopefully you remember that that's ln of x. And the best answer is the absolute value. Plus cosine of x is sine of x. And let's make sure I'm not changing the sign, S-I-G-N. The derivative of sine is positive cosine, so this is good. It's an indefinite integral, so plus c. Final answer. Now let's say you let's say you looked at 1 over x and thought of it as this. Let's just say you did this. And then you try to use the power rule by adding 1. And so you get x over 0 divided by 0. Here's your hint. Once you see dividing by 0, You know you end up in math jail, cannot divide by 0. So that should be your hint to again think of this as 1 over x and try to remember the derivative of what gives me 1 over x. And hopefully you'll remember it's that ln of x. Better pause this now. So this is number 3. We are integrating from 1 to 4 of cube root of y, but we can rewrite it as an exponent. And so to integrate this, we get y to the 1/3, we add 1, so we get y to the 4/3 all over the 4/3, and we're evaluating this from 1 to 4. And so since we're evaluating, we'd rather write it in radical form. And so we'll write this using a radical, so we'll plug in, so we have y to the 4/3, so we're plugging in, oops. So we have 4. Oops. So we have the number 4, and we're taking the cube root of 4 to the 4th. 4/3 in the denominator, so that's 3/4 minus 3/4 cube root of 1 to the 4th. And so we have 3, oops, why is this not working? We have 3/4 cube root of 256 minus 3/4. You can leave this as your final answer, but for those of you who are curious how we can simplify this, we can write this as 4/4. Can we write that as 4 cubed times 4 to the 1? Which means we can pull out a 4 times the cube root of just 4, which gives me 3/4 times 4 is just 3 cube root of 4 minus 3/4. So this could be your final answer, but this is fine. Leaving it just like this, it's fine. For 4, notice we have 4 to -1. So we know that's the negation of -1 to 4. So let's go ahead and integrate this. So it's negative, whatever my answer is negative. So we have 4t minus 2t squared over 2. And we're evaluating this from -1 to 4. I know these 2's divide to 1. And so we have a negative on the outside. We're plugging in 4 first. So 4 times 4 minus 4 squared. Minus, plug in -1. 4 times -1 minus -1 squared. And so let's equals, so there's a negative on the outside. I have 16 minus 16, this is 0. Then I have this negative. 4 times -1 is -4 minus 1. -1 squared is 1. Equals, -4 minus 1 is -5. A negative and a negative is +5. So my final answer is -5. This problem, number 5, here we're taking the derivative of an integral. So I know derivatives and integrals are inverse operations, and since this is only an x, I am not using chain rule. So my final answer is this same function, but instead of a t, I'm using x. So my answer is ln of x minus 2 times x. Finished.